Okay, hi guys, we'll be seeing more on Carnot cycle, but I think in the previous lecture there was some misinformation here. So third step is reversible isothermal ideal gas compression. Okay, and fourth is reversible adiabatic ideal gas compression. So just pardon me for the information. So this is the correct one. So first is reversible isothermal ideal gas expansion, second is reversible adiabatic ideal gas expansion, third is reversible isothermal ideal gas compression, and fourth is reversible adiabatic ideal gas compression. So just keep this in mind. Now let us draw the graph of the same. So first is isothermal process from A to B. Let's say we have temperature T2 and the heat required in the system was Q2. It goes from P1 V1 to P2 V2. Second step is ideal gas adiabatic expansion reversibly. So it goes from P2 V2 to P3 V3, and from C to D, this is D point. So from C to D we would have reversible again isothermal ideal gas compression, and from D to A again we have adiabatic compression. So we know that for an ideal gas U is a function of temperature only. So in step 1 is reversible isothermal ideal gas expansion. So delta U would be equals to 0 because this is isothermal, hence W plus Q2 would be equals to 0, and we can write W equals to minus nR T2. T2 is the isotherm, or rather the constant temperature, which is T2 in step 1. So this would be minus nR T2. What is the ln? V2 upon V1. What is the final volume? Final volume is V2 and initial volume is V1. Okay, so we can write this. In step 2, what we can write? Step 2 is adiabatic process, so Q would be equals to 0, and since Q would be equals to 0, we can write change in internal energy for U2 or delta U2 would be equals to W plus Q. Q is 0, so it is just W, and W would be equals to NCVM T1 minus T2. It is going from T2 to T1. So final temperature is T1 and initial temperature is T2. So delta U would be NCVM delta T. Delta T would be T1 minus T2. Then let's talk about step 3. Step 3 again, it is ideal gas isothermal compression. So delta U would be again 0. So we can write W3 plus Q1 would be equals to 0. Q1 is the heat released by the system here in step 3. So we can write W3 would be equals to minus nR T1 ln. What is the volume here? Volume here would be V4. Final volume and initial volume would be V3. So it would be ln V4 upon V3. Okay, and what happens in step 4? Step 4 is again adiabatic compression of real gas. So Q would again be 0. We can write delta U4 would be equals to just W, and this is W4 in this case, this is W2. Okay, so W4 would be equals to NCVM. What is the final temperature? Final temperature is T2 and initial temperature is T1. It is going from this temperature T1 to this temperature T2. So from here to here temperature would be going from T1 to T2, hence the final temperature would be T2. So it would be T2 minus T1. Okay, so change in internal energy of total Carnot cycle would be delta U1 plus delta U2 plus delta U3 plus delta U4. Delta U1 and delta U3 are 0, as step 1 and 3 are isothermal steps or processes. So it would be delta U3 plus delta U4. So this would be equals to 0. So rather delta U3 plus delta U4 is not 0. Delta as delta U2 plus delta U4 is 0. So total change in internal energy would be delta U3 plus delta U4. Now what we see is as delta U, or rather U is delta U, I think delta U2 plus delta U4, and delta U1 and delta U3 are 0, as step 1 and step 3 are isothermal steps. Okay, now we also know that U is a state function and as u is a state function and this is a cyclic process overall, so we can write that delta u total would also be 0. So from here we can write delta u total would also be equals to 0. So this implies delta u2 plus delta u4 would also be equals to 0. Okay, so we can write that w total plus q total would be equals to 0, and we know that q total is nothing but q1 plus q2. So we can write that w total would be equals to, and we also know that w total would be equals to w1 plus w2 plus w3 plus w4. w2 and w4 would be equals to 0, because we know that w2 is equals to NCVM T1 minus T2, and w4 is equals to NCVM T2 minus T1. So these two cancel out each other, hence w2 plus w4 is 0. So w total is nothing but w1 plus w2. Hence w total can be written as, what is w1? w1 is minus nr t2, w1 is nrt2 ln v2 upon v1, and w4 is w3 rather is nrt minus nrt1 ln v4 upon v3. So just adding them both, so it would be minus nrt2 ln v2 upon v1, and what is w2? w3 rather, this is w3. w3 is nrt1 ln v4 upon v3. Okay, and we can also write that v2 upon v1 is equals to v3 upon v4. How can we write this? So let's see the derivation of the same. So from step 2, which is adiabatic ideal gas expansion, we can write that T2 V2 to the power gamma minus 1 would be equals to T1 V3 to the power gamma minus 1. So we can write T2 upon T1 as V3 upon V2 to the power gamma minus 1. Similarly, from step 4, which is again adiabatic ideal gas compression, we can write T2 V1 to the power gamma minus 1 would be equals to T1 V4 to the power gamma minus 1. How can we write this? Because here and here we are comparing the constants at these two positions and then at these two positions. So at this we have temperature T2, volume as V2, so we can write T2 V2 to the power gamma minus 1 would be equals to, here temperature is T1, volume is V3, V3 to the power gamma minus 1. Okay, and here it's also an adiabatic process, so we can write that here temperature is T1, V4 to the power gamma minus 1 would be equals to T2 V1 to the power gamma minus 1. Okay, so just using these two equations below also. So first equation which we have used was T2 V1 to the power gamma minus 1 would be equals to T1 V4 to the power gamma minus rather the first equation was T2 V2 to the power gamma minus 1 would be equals to T1 V3 to the power gamma minus 1, and here we can write T2 V1 to the power gamma minus 1 would be equals to T1 V4 to the power gamma minus 1. If you are not able to recollect or follow from the above step, I am again drawing the graph so that you have a better understanding. So this was T2, this was T1, this was P1 V1, this was P2 V2, this point was P3 V3, and this point is P4 V4. Now across this adiabatic process we can write that T2 V2 to the power gamma minus 1 would be equals to here temperature is T1, V3 to the power gamma minus 1. This is the equation number 1, and here we have on this adiabatic curve we have here we have T1 V4 to the power gamma minus 1 would be equals to, here we have T2 which is temperature, here V1 to the power gamma minus 1. I hope it is clear by now. Okay, just erasing it again. So now we have just equated the equations. So from here we can write that T2 upon T1 again can be written as V4 upon V1 to the power gamma minus 1. So from these two equations we can write that V3 upon V2 is equals to, from these two equations we can write that V3 upon V2 is equals to V4 upon V1. So just arranging it to suit this case, that we can write from here, cross multiply this, so we can write V3 upon V4 would be equals to V2 upon V1. So from this we can conclude this. So we are writing, we have V2 upon V1 equals to V3 upon V4. Okay, so let's put the result in the above equation. So we would be getting that if we replace this term here, V4 upon V3 with V1 upon V2, so we will be getting something like this. So I'll again write the two equations lower down. So this is equation number 1 and this is equation number 2. Okay, so just writing them again. So we have got W total S minus NR T2 ln V2 upon V1 minus NR T1 ln V4 upon V3, and we have got relation that V2 upon V1 would be equals to V3 upon V4. So just put the value of V4 upon V3 from this result into the above equation. So we will be getting W total as minus NR T2 ln V2 upon V1 minus NR T1. So just convert it into V3 upon V4. So add take the minus sign from here into the log factor. So V3 upon V4 it is getting it got converted, and V3 upon V4 can be written as V2 upon V1. So now we can write W total as NR ln V2, or rather NR T1 minus T2 times ln V2 upon V1. So this should be the total work done in the Carnot cycle. Okay, so with this we come to the end of this lecture. In the next lecture we'll be talking on the efficiency of heat engine or Carnot cycle. So till then, good luck and goodbye.